Hi folks, welcome to the Age of Asparagus and part 3 of making a 3D top-down shooter in Godot. By the end of this episode, we'll have some enemies with a basic AI that will seek out the player and even avoid obstacles using Godot's Navmesh and some simple pathfinding. Okay, let's make some baddies. Let's start with a new scene. Up in the scene menu, we'll hit new scene, and other node, let's make the enemy a kinematic body, and we'll add a mesh, so add a child node. And we're going to choose a mesh instance, and in the inspector with the mesh instance selected, we'll click the empty mesh, choose a new capsule mesh, and then expand the transform in the inspector, and we'll rotate on the x-axis by 90 degrees, and we'll translate it up in the y direction. I think it's 1.4. That looks good. Okay, let's give the mesh a color. We'll expand the material, click on the empty material, add a new spatial material. We'll select that circle and change the albedo to some sort of greeny color. Sure. Let's select the kinematic body, and we can right click and rename, or you can double click it, and we'll call this enemy. Control S to save, and we'll save it as enemy.tscn. And apparently I already had one, so let's go over to the level, and we'll drop an enemy into the level. We can move them over to the side a bit. Now, you notice if we play, the bullets go right through the enemy. We can fix that now. The enemy has a message here, which is that it has no collision shape. So those bullets can't collide with it anyway. So let's go to back to the enemy, and same message here. We need a collision shape, so let's add that. We will add a child node, and let's choose a collision shape, and we want that shape to match the capsule, so let's go over into the inspector, and in the empty shape we'll choose a capsule again, and then we'll do the same thing. We'll rotate it 90 degrees about the x-axis, and we'll move it up 1.4 on the y-axis. That looks good. Okay, we don't have any more error messages. We'll also need to do that for our bullet, so let's open the bullet scene. If we want our bullet to collide with anything, including the enemy, we're going to need to add some collision detection objects here. So let's go to the bullet, and we'll add a child node, and we're going to choose a collision shape here. And this collision shape, we get an error message. Collision shape only serves to provide a collision shape to a collision object derived node. We didn't get this message in the last one because our enemy uses a kinematic body, which handles that for us. But here we just have a spatial. So we actually need to add an area to this bullet. So let's right click the bullet, click add child node, and we'll type in area. And remember, you want the pink one here, not area 2D. So we're going to create an area, and then we're going to place the collision shape into the area. And the collision shape, let's give it a shape. So in the inspector, we'll click the empty shape, add a capsule shape. Nope, this isn't a capsule. We want a box shape for this one. Now, the Godot docs tell us not to scale collision shapes in the transform. So you're supposed to use these guys here. Make sure you have the snapping off there, or you might not be able to get to the size. So I'm going to hit 1 on my number pad to go to front view, and we can get this shape nice. And then I'm going to hit 7 on top view just to make sure. 3, 1, 7, all looks good. Okay, yeah, looks like we're good. Oh wow, what's that thing? No, it's not good. Which one did I miss? 3. I was zoomed out too far. Okay, let's get that in there. The side view. Okay, now middle click and orbiting around. Looks good. So the bullet should collide, and the enemy should collide. Let's hit Control S to save the enemy. I see these little asterisks that appear. That means you've made changes that haven't been saved yet. So get in the habit of left hand just Control S-ing all the time. Let's see what happens when we shoot. It might be detecting those collisions, but we're not doing anything about it, and we're not getting any feedback. So we wouldn't even know if it was working. Let's get rid of some of these pew-pews and stuff so we can add some more currently relevant output. So I'm going to go up into the level script, and then under search, go find in files. And if I just type print with an opening parentheses and click find, now in the bottom here under search results, you'll see a whole bunch of our print statements. And I can just comment out the ones I don't want appearing right now. I don't want it to pew, because we're going to be doing a lot of shooting, and we don't need it to tell us when to do that. We can also get rid of that typo. Any of these, mouse position, those are all commented out already, so that should be good. Now let's do something, give ourselves some feedback when we hit. So let's go to the bullet, and we'll open the bullet script, and in our area, which is what's going to be detecting the collision, we're going to go over to this node beside the inspector, and we're going to go body entered. So this is a signal that will fire and run a method for us if we turn it on every time the bullet enters another body. Now that could be a rigid body or a static body or a kinematic body. So let's click body entered here, and at the bottom we'll click connect. You could also double click it, and we want to add that to the bullet script. So anytime this enters something, let's see if this works. So we'll just go print I hit you, and then I'm just gonna have a comma here, and then this method will give us the body that was hit by the bullet. So I'm just gonna print the body out there too, so we can see what's going on. There we go. See, look, I hit you, the kinematic body. That's good. Okay, so we have a collision. We should probably get rid of the bullet when that happens too. So let's just queue free it and run it again. Right on. Now, how about we have this enemy navigate around and try and move towards us and attack the player. To do that, we need to do two things. We need to create a navigation mesh on our level so that the enemy knows where it can move and it can find a path. And that's the second half. We'll have to use some pathfinding to generate a path and then get the enemy to move along that path. Now, that sounds quite complicated, and in the background I'm sure it is, but Godot makes this pretty easy for us. So let's go to our level, and with the level selected, the base level selected, we're going to add a new child node, or you can click that plus, and we're going to add a new navigation node. There it is right there. And underneath here, we can generate a mesh that the enemy can follow. We're going to add a child to the navigation node, and that is a navigation mesh instance. Now this navigation mesh instance will take any geometry that is placed as a child to it, and it can take that and then generate a mesh that we can use to calculate some pathfinding and stuff. So you can see an error here because it doesn't have any mesh, and it actually doesn't have a mesh resource. So this is the node. If we go over into the inspector and click Navmesh, see Navmesh, click the empty Navmesh, and we're just going to create a new one here. It's got some settings we can edit later if we want. You can get to by clicking the Navmesh. So right now, it's not going to do anything because there's actually no objects underneath it. However, our CSG ground, that has everything it needs. We can just move it underneath the nav mesh and it should work. So click on the navigation mesh instance, and we're going to click up at the top, bake nav mesh. And you should see here, it has calculated the travelable portions of our map. I'm going to hit Control A here to add another CSG cube. So let's add a couple boxes, and I'm just going to move it up and over. Let's add a few, is that right? Yeah. Let's add a few obstacles here. So with our CSG box, I'm going to click on in the inspector, empty material, new shader material. Oops, that was wrong. Let's go back. Wrong kind of material. Let's do new spatial material. There we go. And I'm just going to change the albedo. What color do we want our I don't know. I'm going with the purpley things in this. I'm not sure why. Okay, so we'll have a purple obstacles, and you can duplicate that with Control D, and we can move around. We could make some of these a bunch of different sizes, move them around. Let's make one more of these right here. Control D to duplicate, and I'm going to expand that one out. One. There we go. So we got a little course here, and if we go over, you'll notice now this, if I select the navigation mesh again, it's not going to take into account these boxes because we need to re-bake the nav mesh. If I do that, it still doesn't take them into account, and that's because I didn't create them as children of the nav mesh. So I'm going to move all of our obstacles into the nav mesh, select it, bake again, and look at that. Hope you can see that. If you zoom in here, you can see that the nav mesh is now avoiding our obstacles. Excellent. So how do we use this mesh? How do we get our enemy find a path along this mesh to our player? And the reason we need this is because if our enemy, for example, starts out behind this cube, We don't want it to move straight through that block. We want it to find a path to the player that is within this navigation mesh, this little blue area. So it should be going around one way or the other. So let's go back to our enemy, and we're going to create a new script called enemy, and we're going to have to script it to use that navigation and go find the player. Okay, so we're going to need a reference to the navigation node and the player node. So let's create some onReady vars variables here, and we'll create the nav, and I'm going to do this probably a bad way to start, but just to get it working. The nav is not in our current tree. It's not related to our enemy. So it'll only be able to find the nav once the enemy is instanced. And where is the nav? Well, if we collapse everything here, you see the nav is on the same level as the enemy. So if we're in the enemy script, we actually want to go up one to the level and then find the nav from there. And we can do that. If you've ever used a terminal and tried to CD around, you can use a ... to go back one. And that's what we're going to do. We're going to go ... back one, and then we're going to get the navigation node. And we need to make sure that it is spelt the same as this. Capitals are important. Whoops. Go to the enemy script again. We're going to do the same thing with the player. Let's copy and paste that. And this time we're going to have a reference to the player. And the player again, we have to go back one, and then we'll go get the player. And make sure you have the same name as this player with a capital P or whatever you've named it. So I'm going to Control S, save that level, Control S, save that enemy. Okay, in our ready function, let's use the nav to generate a path to the player. So how can we do this? The navigation node has a built-in method to create a path for us. So we're going to need a variable to hold that. And the path it generates is a list of points. So let's create a new variable called path, and we'll make it an empty list. Now hopefully you've had a chance to play around with lists, either in Python or GDScript. I'm going to assume you have a basic idea of how they work. So our path in the ready method now is going to equal, we're going to generate that from our nav node. And the method we're going to use is called getSimple. Now it's not auto-completing here because the editor knows we're getting a node of some kind, but it doesn't know what kind. So when we create this variable, we can let it know what kind it is. We can let it know that it is a navigation node. Just because its name is navigation, we could call any node a navigation, but its actual type is navigation. So now when we do this, it should know that it has the method to get a simple path. There we go. So the simple path needs some info. What do we need? It's not telling me. So let's look that up. Search the help for get simple path. There it is under, that's navigation 2D. So let's use the pink one. Get simple path. Where are you? There it is, get simple path. So it just needs a start vector and an end vector. That seems pretty obvious. The start vector would be where the enemy is now, and the end vector will be the player's position. Back to our enemy script. We're going to start at the enemy's position. So let's use the global transform. Remember, we're in the enemy right now with the enemy script, so the global transform will be the transform for the enemy. And let's get the origin. That's its position in world space. Ooh, I don't know what happened there. Origin. Okay, that's the start. And the end position is going to be the player's location. So let's go, same thing. We'll go player, global transform, globe. Okay, again, notice how this is not auto-completing, and that's because we didn't tell it what kind of node the player is, so it doesn't know if it has a transform. I think the player is a kinematic body, right? So let's give it the kinematic body so that the editor here can give us the proper hints. So global transform, good, and we're going to go .origin again. Okay. I'm just going to expand this a little bit so we can see the whole text. Okay, go back here and let's just see what kind of path it comes up with. Print the path. So when we run this, we should see some path. You see some errors down here. Node not found. / navigation / player. That's because they don't exist here. It'll only be able to find them when the enemy is instanced inside the level. So you can see here, it's printing out the path. The path is a list, you can see the square brackets, of vector 3s of x, y, z coordinates. And it looks like it has 1, 2, 3, 4, 5, 6, 7, 8 points that it's using. Probably like, 1, 2, 3, 4, 5. Well, that's a lot of points. Okay. The green guy, it's creating a path around that block to our player. That's good. That's what we wanted. Now for the harder part of moving along that path. So I'm going to Control K out that. So let's add a physics process where we'll do the movement. So we need a vector that'll be the direction that the enemy will move in, and then we're going to move him with move and slide. Actually, maybe that's not so hard. So let's create a variable direction, and the direction is going to equal the difference between the first node and our current location. So how do we get the first node? Well, path is a list, and if you remember, we can get the first element in a list with 0. Remember, these lists are 0 indexed. They start at 0, 1, 2, 3, 4. So that should give us the point we're trying to get to in our first leg of the path, and we want to subtract our current position, the enemy's current position. So global transform.origin. Now we have a direction. Let's move in that direction. Move and slide. And we need to give it a velocity, so we'll move in the direction. Now the direction here is going to be a vector that points from our current position to the first node in the path. If you imagine the path as a bunch of connected nodes. But we only want the direction. We don't want the length of that vector, because that'll control how fast we go. So if the node is far away, the enemy would actually travel faster. So instead, let's normalize this. So it has a length of 1. So notice how it won't autocomplete normalize for me either. And that's kind of annoying, because I don't actually remember. Is it normalized? Is it normalized? Is it a variable, or is it a method? So let's tell the editor here that direction is a vector 3. And we can do that by, after we declare a variable, we can add a colon and just say vector 3. And that's saying direction is a vector 3, and we're going to set it equal to this. So now I hope if I go dot, I should be able to find the proper normalized. And yes, it's a method. Okay, so we're going to move and slide in that direction by a certain speed, which we haven't created yet. So let's go create a variable speed. We'll set it equal to, I don't know, 2, which should be pretty slow to start, just to see if it's working. And let's run it, see what happens. Nothing happens. Okay, time to debug. All right, well, let's start by printing out the direction and just see what that looks like. So let's print direction. I'm just going to go dir and then give the direction variable and see what happens here. This should happen every time, and maybe I'm going to uncomment that with Control K just so we print the path and make sure the path is generated. Oh yeah, so the direction, it looks like it's going nowhere. It's like bouncing back and forth from its current position. You know what? Maybe that first node is where it is, or it's so close that it just reaches it, and then we never actually tell it to get to the next node. We should do that. Let's create a new variable called the current node, and that's we'll set it to 0. And instead of always going to the first node, that's the first, if we scroll up, can I get there? There it is. So I'm calling these nodes, this point, this point, this point. This is the first node in the path, the second, the third, the fourth, the fifth. So we want, once we get to the first one, then we want to go to the second one, then the third one. Okay, so instead of going to 0, we're going to go to the current node. And we got to check if we've reached the current node. So after we've calculated the direction, now remember, the direction, before we've normalized it, is a vector that points from our enemy to that node in the path. So we can check its length. Get the length, that's a method, of that leg of the journey. And if it's less than 1, let's just say 1 if it's within 1 unit of whatever that is. If it's close enough, we can edit that later. Then what we'll do is we'll update the current node to the next one by adding 1, plus equals 1. And if it's not, then we will move and slide. So I'm going to delete this print statement now, and we're going to move and slide in that direction. Actually, you know what? Let's keep that print statement because it'll be interesting to see it change as we switch nodes. Okay, how about now? Are we going to move anywhere? Oh, it's moving! That's cool. So look, you can see it was doing stuff, and it was working, and it was moving towards our character, and then we got an error because we never actually tell it to stop at the end. So what's going to happen is, remember that first one we checked? It had 8 nodes in the list, 8 legs of the journey. Well, we go right off the end of that. We just add 1 and go looking for the 9th, and that causes our see index 8. Remember, it starts at 0, so 0 to 7, that's the first 8 legs, and then we go to the 9th one, which is the 8th index when current node equals 8. It doesn't exist, so the program's going to crash. So before we do all of this, let's highlight all this tab indent. If the current node is less than the path.size, size. So size, this is a list or an array, and size will give us the length of that list. So we don't want it, if the current node is 8, then that's too far, because 8 is not less than 8. It needs to be less than, because remember, the current node will always be one below, because it starts at 0. Okay, let's add that guy. So what happens if the current node is less? Well, we don't have to do anything, because we're there. Is that going to happen without crashing? He made it. And look, it stopped. He actually stopped moving because he made it there. But if I move, oh wow, look, my player can go right through these obstacles. We should deal with that. He doesn't actually update. In fact, if I run this and I move, all the enemy does is go to my initial position and thinks it's got me. So what we need to do is we need to recalculate the path every once in a while. So let's just move this code into its own method. So let's go func update path. We'll call it update path. And it doesn't need any parameters. Ooh, actually, you know what? Let's give it a target position. So it could be searching for the player, and it will in this case, but this way we can actually have the enemy go other places too later on if we want, and we can just use update path and give it a place we want it to go. So let's copy this here. And this is a bit annoying here, so I'm going to shrink this down a bit and this to try and give us more room. We don't necessarily want the player's global transform. We're going to go towards the target position, whatever target position we pass to that method. Okay, and now we can call update path, for example here, and we'll update the path and we'll give it the player's origin, global transform origin, so the player's position. So nothing here has changed. I'm going to get rid of that comment. We've just moved this code into a method, so the same thing is going to happen here. It's not going to update where it goes. Nope. So let's move the update into physics process. So now it's going to recalculate every frame. And we either need to delete ready or add pass there so it can ignore. Okay, what about now? Okay, it's moving towards me. Oh, wow, wow. Oh, wow. It like went right through that thing. It seems like the path was correct, but something weird happened that allowed it to get confused and clip right through that. And now it's stuck. Good, well, I'll shoot you. Pew pew. Wow, and notice that I can shoot right through the obstacles as well, so we should fix that. Okay, let's go back into our level and expand the navigation. And one thing I forgot to do is for our obstacle boxes, if you go over here, we need to make sure we tell it to use collision. So it has a built-in collision shape, right? Which is what makes these things handy. And so I'm going to click all of my obstacles and turn on collision, and let's just make sure that means we can't. There we go. Yep, kind of. Although I'm like the gun is clipping with the obstacle. I can also fly off the edge. We haven't dealt with that. Okay, yeah, for the most part, although I can shoot through sometimes, it blocks most of it. Looks like a bug for us to fix later. The other thing was we don't want if I select the navigation mesh so it's a little brighter, I don't want the enemy to be able to get too close. I'm going to turn off snapping, and I'm going to go into top view, and I'm going to come down here, zoom in, my scroll wheel, and I'm just going to grab him and move. So if you notice, the origin of the enemy is the point where it's going to get close. Now if you notice how close it gets, it actually starts clipping, right? And that's too close for us because top view with the number 7. We're not stopping exactly at the node, right? We're just checking if we're within one of it. It might have passed it. You know, that move and slide, it depends how far it goes in a frame. Ooh, geez, that's weird. So let's just give it some more space away from the obstacles. And then I think that'll fix our problem as well of it accidentally getting outside somehow. So if I go to my navigation mesh and I click on the nav mesh, there's a whole bunch of options here which are really cool. I'm just going to expand agent, and radius is how far away from any potential obstacles it's going to consider. And let's say 1. Now our enemies have a radius of 1. They're like width of 2 units, so maybe we'll just give it a little bit more than that. Oops, we got to be on the nav mesh. Let's give it 1.2 to be safe, and then we're going to rebake the nav mesh. Is that far out enough? Let's give it 1.5. Now notice it also goes from the edge of the world to here. Whoops, max climb. I didn't want to change that. Maybe that was the problem. Is that what I changed by accident? What I meant to change was the radius. 1.5. Rebake. There we go. That looks good. And you're going to want to make sure, like, if you have one of these obstacles that are really close and then go to your nav mesh and bake it, it won't actually be able to get behind it. So just remember that. There we go. That's enough of a path. Okay, so now let's move him. Oops. I'm going to hit Control Z. I don't know if I like clipped him into the ground. Let's move him back over here. We'll hit play, and we'll see. That's nicer, right? Like not clipping through the enemy, clipping through those boxes. He's getting really close to that one though, but it looks okay. You can always increase that from 1.5 to ooh, this is pretty cool, eh? So why don't we add that collision shape to our character here so he stops going through the obstacles as well. So we'll go to our player, and before we do this, let's make our player its own scene. So select the player, right click it, and choose Save Branch as Scene. We'll call it the player.tscn. And now it's got its own scene. We can double click the scene and open up the player by itself. So in the player doesn't have a collision mesh. So let's create one. Right click, add child node. Over here in my recent, I should have a collision shape. There it is. And we're going to do it similar to the enemy. We're going to select the collision shape. And over in the Spectre, we're going to click the empty shape, add a capsule, transform, rotate it about the Z-axis by 90 degrees. And that one we don't need to move up. That one just fit right on. And is that just going to work? Yep. Cool. Okay. Player can't go through. The gun still can. That's we can cheat and shoot through. Okay, the last thing we need to do for the enemy's navigation is we don't want it to update its path every physics process here, about every frame. If you have 50 enemies on there, that's all going to be pretty computationally intensive and kind of pointless. It's generating a whole path every single frame, so we don't even need the rest of the path. We only really need the next node, right? So why don't we instead update the path at some regular interval? And we can do that by adding a timer to our enemy. So select the timer, and in the inspector, let's start with a wait time of 1. We want to make sure auto start is on so that it starts counting down as soon as the enemy is added to the scene tree. And I'm going to Control S and save that. We'll go back to the enemy, and we want a function that runs every time the timer triggers or counts down from 1 second. So back, let's select the timer, and over we'll hit the node tab, and we'll connect to the timeout signal. We want to connect to the enemy script. There it is, on timer timeout. So when the timer times out, instead of updating the path in the physics process every frame or so, we want to update it in the timeout. And just to make sure it's working, we can add a, let's print looking for player. And so that should happen right now every second, because if I go back to the inspector for the timer, our wait time is 1 second. So we can't tell because we're printing way too much stuff. So let's go back here, and we don't need the direction anymore. Actually, we'll get rid of that. That was printing too much stuff anyway. Let's run this, and look, looking for player. It's updating every second. It seems a little slow. Maybe if actually, you could probably change that time based on what kind of enemy it is and how smart it is or how observant it is. But let's set it to something like 0.25, a quarter of a second. So 4 times a second, the enemy will recalculate the path, which, yeah, that's a little better, right? Okay. So I think we're done here. The only thing I noticed that's really bugging me, see this little shadow on the boxes? That looks bad, right? So this is something we can do if we go back to our level and we select the directional light. There is, I'm just going to zoom in with the scroll wheel, shift middle click and zoom in here. This here's shadow, so we can adjust something called the contact shadow. Make sure the shadow is expanded in the inspector, and then this contact value we can increase. And as we slowly increase it, you can see the shadow is going to get closer and closer to the object. So I'm going to increase this. You can see it gets closer, but if you go too far, weird stuff's going to start happening. Like, look over there. It's getting crazy, right? So we only want to increase it enough that it connects our shadow, and I'm just going to set it to a value of 0.5. That seems to work well. And now if I play, we have an enemy that follows us. We have some obstacles that our enemies have to go around and block our bullets, and that's pretty good. So let's add a few enemies. Let's go to our enemy scene here and drop another enemy on. I'm just going to move him down beside the first enemy, enemy 2, and where'd you go? Let's move them a different direction and hit play. And there we go. Look at that, 2 enemies trying to follow us. It looks like we have a little bug here where the baddies just kind of stop mid-path, and sometimes they start going again, but they never actually come in. Oh, he kind of came and got me, but now he's stopped. Okay, and I think I know what I forgot to do. So let's go to the enemy script, and in our onTimeout function, when we update the path, we don't tell it to restart from the first node again. So we've been incrementing the node by 1 as the enemies go along each leg of the journey, and when we regenerate the path, we need to start back at node 0. So the current node to 0. And that should solve our problem. Let's try that. They should come right up to us. These guys are pretty slow, eh? Yep. And now they won't pause mid-path. And we have something closer to a game.